This is the fifth and final video in AudioGuide's tutorial series, and I'll be talking today about working with the output. The idea of this video is I'm going to be speaking to you a little bit about the different kinds of output files that are available for you to use in AudioGuide, and also give you some ideas about how you can parameterize and change those outputs so that you can more easily incorporate AudioGuide's materials into your musical workflow. I'm going to speak first about some of the output files that are based around csound and talk to you a little bit about the ways you can change and manipulate those. I'll then talk about some of the output files that work with MaxMSP, including an output file that's new to version 1.6 for working with Bach in the MaxMSP environment. And then finally, I'll speak a little bit about some more advanced output options for those of you that are inclined to program or even work with Python. Before I get into talking about individual output files and how you can work with them, I want to make a brief comment about all the different output file possibilities there are in AudioGuide. You'll see in the documentation there's a section called concatenation output files. Here you'll find a list of all the files that AudioGuide can create that have the concatenated sound selection data embedded in them. You'll also find a list of other output files that the AG concatenate script can create that give you some more information about the concatenative process or the target sound file segmentation or descriptor information, etc. Each of these output variables, each of these output file variables that AudioGuide lets you work with have the same format. They can either be set to none, the Python variable none, which tells AudioGuide not to write that particular output file, or they can be set to a string, which tells AudioGuide to write that output file, and the string specifies the location, the path that the output file should be written to. So in today's video, I'm going to be working first with this relatively simple options file. And you can see here that if I change the default value of csound at CSD file path, by default, it's output.output.csd. If I change it to none instead and run this concatenation Python 3 AG concatenate and the name of the options file, AudioGuide's going to run as normal, but it's not going to create any csound output now because you've set CST file path to none. So by default, csound writes a couple of different output files. When you first download csound and run it for the first time, it's going to create the csound output files, a Bach output file, some label files. All of these write to disk pretty quickly. They don't slow down your workflow too much to have the default group of files written that AudioGuide has. But I do want to say one sort of general comment that I haven't said yet in this tutorial about working with options files and their defaults. So if you find yourself working with AudioGuide a lot and you kind of find a particular way you want to work, let's say you decide you never want to work with csound and you only want to work with the Bach file path output, it's actually possible to edit in AudioGuide the default values to change them from what they're given in the documentation so that you don't actually have to repeatedly write certain choices or preferences you have about which output files are written, or indeed any of the variables that are in the AG concatenate script. You can edit those by going to the AudioGuide folder that you download. Within that folder, there's another folder called AudioGuide, and there's a file here called defaults. This contains all of the default settings for all of the parameters of the AG concatenate script. And so if you come in here and you set CSD file path to none, it will not write a csound file or render csound for any of your concatenations you run in the future. So you can edit some important information about the output files here to sort of permanently change the default values for the version of AudioGuide that you've downloaded on your machine. So let's talk a little bit about first csound output files. So by default, if you don't specify anything about file paths, like I said, AudioGuide will automatically render a csound file that you can listen to. It'll create a csound score and it'll create a csound audio file that you can listen to and audition quickly from the command line. So here's this options file that I'm going to be working with first. It's really similar to the sort of early examples of AudioGuide that come with the program. I'm using this cage sound file from the distribution as the target. I'm using the Lackaman sound file that's been segmented as one of the corpus files, and the second corpus file, I'm using another file from the distribution, which is a recording of some sounds made with the computer heatsink. The search variables, similar to something that I did in example 2 of video 3, where I talked about ratio limit followed by closest percent followed by closest. And you can see related to video 4, the superimposition of sounds, I've set the maximum number of corpus segments that can be picked for each target segment to 10. So just starting off with this options file as it is, here's how things sound. And by default, just based on the structure of the output variables as they're given in the defaults.py file, everything's written to this folder called output. If we open the output sound file in Audacity, excuse me, you'll see a mono rendering of the sounds you just heard from the concatenative process. So let's talk a little bit about some of the controls that AudioGuide gives you to change or parameterize the csound output. If you go back to the documentation, you'll see there's a section on csound rendering. These are all variables you can add to your AudioGuide options script that change the behavior of the csound rendering to get different kinds of outcomes. So some things are relatively simple. You can change the csound sample rate. So if you want to work in 96K, AudioGuide will let you do that by simply changing csound SR. Now, if we look at the output file that was created, it probably doesn't say it. It does say it with OS X's file system. It says that the sample rate is now 96K. You can change the bit rate of the csound file. You can change the ksamps, which is the kind of the block rate that csound works with. That's something you can look up in csound's documentation if you're interested. You can also normalize your csound output file. So there's a argument called csound normalize that you can set to true. There's also a csound normalized peak dB, which by default is -3, that you can also change. So there's a couple of options that are given here for the csound output file that are useful and relatively straightforward. If I set csound play rendered file to false, AudioGuide will still run csound, still create the file, but it's not going to play it back at the command line, which may help you work with the program a little bit more easily depending on how you integrate AudioGuide into your workflow. And so these are kind of the basic csound rendering controls for making it easier to use AudioGuide in your project. There's a couple other csound arguments that are interesting and I want to spend a little bit more time on because they're powerful when it comes to thinking about the csound output. The first is that csound gives you some controls for stretching the duration of the selected corpus segments to fit the target segments. So essentially what it's going to do after concatenation happens is look at either, whatever the selected corpus segments are for a segment of John Cage's voice. It's going to try to stretch their duration. It is going to stretch their duration to fit the duration of each of John Cage's utterances. So by default, this is not turned on. It's set to a value of none. There are two options if you want to turn it on. The first is a string called transpose, and this will do essentially tape head transposition. It will play each segment from Locomon or the heatsink slower or faster so that it matches the duration and the temporality of John Cage. So here's some differences there. You'll hear some things that are transposed much lower because they're stretched so that they fit John Cage's temporality. There's also an option here called PV, which does the same thing, the same kind of stretching, except instead of using tape head transposition, uses a phase vocoder to accomplish the same task. You'll obviously not hear the transposition artifacts now in terms of pitch, but you'll hear some transposition artifacts in terms of phasiness. That's a little bit about csound stretch corpus to target dir. The final variable in the csound rendering section is probably the most interesting when it comes to thinking about working with the csound's sound file output in a flexible way. This is called csound channel render method. We've seen this a couple of times in some of the tutorial videos because I've used the setting target output mix so that John Cage's voice is put in the left channel. All of the selected corpus sounds are put in the right channel. So you can quickly audition the similarity or the temporal alignment between the two.
The lecture is so soon.
But there's a bunch of other settings of this parameter, csound channel render method, that are really interesting. By default, it is corpus max. And essentially what this says is we're not going to include the target. The only way you can hear the target sound and the corpus sounds is by setting target output mix to true, setting this variable to target output mix. If you pick any of the other options, you'll no longer hear the target. And essentially what corpus max says is it says, okay, I'm going to take the maximum number of sound file channels that I find in the corpus and use that as my channel count for the output sound file. The reason, of course, being that, you could have a stereo file, Lokomon could be in stereo, heatsink could be in mono, and therefore you'd have a different number of sound file channels for different members of the corpus. Corpus max essentially says I'm going to take the maximum number of sound file channels for the sounds that were picked in the corpus, use that as my max, and sounds that are a lower channel number are going to get mixed in. So if Lokomon was stereo, it would be stereo by default, and heatsink would be mixed into left and right equally because it's a mono file. In this case, both of these corpus files, just to make the distribution smaller, are mono files, and that's why by default when I opened the sound file in Audacity last time I ran it, it was a mono file. So by default, corpus max defaults to 1 because both of our corpus sound resources are monophonic sound files. However, there's a bunch of other interesting options here that you should know about. One is one channel per voice. This essentially says, okay, the number of voices in the corpus, meaning the number of entries in the corpus, is going to determine our overall sound file channel count on the output side of things. So now we're going to make a 2-channel file. And all of the sounds from Lokomon are going to get put into channel 1. All of the sounds from heatsink are going to get put into channel 2. You probably can't hear this over the Zoom recording I'm doing because it mixes everything to mono, unfortunately. But hopefully just visualizing in AudioGuide will show you that indeed the heatsink sounds, which are fewer in number in this particular concatenation, are in the right channel, whereas the left channel has the Lokomon samples. So here the order of elements that are written into the corpus are going to determine the order of which sound files from the corpus are going to get put into what channel. One final option that's really useful is 1 channel per overlap. It works in a similar way to 1 channel per voice, in the sense that it's going to create an output sound file with more channels and parse corpus selections based on some relevant data. But here, instead of using the corpus index as the information which determines what channel selected corpus segments are put into, it's going to use the total number of overlaps. So because in this script, we're saying that the maximum number of overlaps, the maximum number of sounds we can pick for each target segment from the corpus is 10. This will create up to a 10-channel sound file where each individual utterance from the corpus will be staggered in a different channel so that no corpus sounds are mixed together. I'm going to run this really fast. Sorry, there it is, Python 3. So the playback is going to sound strange because by default, OS X, when you play back at the command line, only plays channels 1 and 2. But now when we open this sound file in Audacity, you'll see what I mean. Now we have looks like a 9-channel output file where each individual utterance from the corpus is placed into a different channel so that no 2 corpus sounds are mixed together. This is a large channel count for a sound file, but this is super useful in working in DAW type situations where you want to have sort of independent control over different elements of the corpus and how they interact with each other. That's the final csound rendering method that's useful, is 1 channel per overlap. You'll see that there's also 1 channel per instrument. I'll talk about this when I do a separate tutorial video on writing for instruments with AudioGuide. It does probably what you would guess. You define a certain number of instruments in the score, and it puts each of them in its own channel in the output sound file. One final thing to say about csound is that in addition to the csound sound file renders, there is also an output file called csound score file path, this is simply going to write, by default it's none, so it's not written, but if you change that to path, it is going to write the concatenative selection into a text file in a relatively simple format. There it is. That just lists the data from the concatenative process. So, in csound score format, essentially. So if you just want to grab the score and not deal with the csound CSD file, you can do it that way. I want to move now to talking about some of the outputs that are available for interacting with MaxMSP. By default, AudioGuide creates a couple of files in the output folder that can be used in Max. The first is this output.maxmsp.json file. This will include all the information about the concatenative process, meaning all the sounds from the corpus that were picked in order, as well as a full list of corpus files that you can use to load those files into buffers. AudioGuide comes with, in the MaxMSP folder, a Max 7 Java player by Gilbert Nuno. I actually can't demonstrate this for you in this video because I don't have Java installed on the machine I'm currently recording on, unfortunately. But essentially, it's a patch where you can load that JSON file into Max. It will load the buffers for you, the buffers that the concatenation uses, the sound files that are in the concatenation. And then you can play back and do different kinds of transformations with the concatenative data from within Max. So the second MaxMSP output file that AudioGuide creates by default is new as of version 1.6, and this is the Bach file path variable. By default, it is set to write to the file output/Bach roll, and so anytime you run a concatenation by default in AudioGuide, it's going to create this Bach roll output file. Essentially, what the Bach roll output file has is the information about target and corpus segments, their timings, some other data that you can add, which I'll talk about in a second, formatted in Bach's gathered syntax so that you can load concatenated data into Bach and MaxMSP to visualize it. So before I open Max and show you how that looks and how it works, this is the options file I'll be using. It's very similar to the last one, except that I've added an additional member of the corpus, which is a folder of pre-segmented violin sounds that are muted pizzicato. And the search is somewhat similar. I've limited selection, the density here, to being a maximum of 3 corpus segments for each segment of John Cage's voice. I've got some other parameters down here that I'm going to uncomment and talk about in a second. But first, I want to just run this in AudioGuide. And I want to run it in AudioGuide's interactive mode. This is also new as of version 1.6. You run the AudioGuide concatenate script with the flag -i. And essentially what this will do is run the program, and AudioGuide will stay open and watch your options file for saved changes and then rerun the code again to update the concatenative output based on the changes you've made. This is documented in a video after the 5-part tutorial on the tutorials page. So I'll run interactive mode. This is our output. So the cool thing about interactive mode, of course, is that you can change. You can see AudioGuide is still open in the background. You can change anything about the concatenative script you want. Here I'm going to change the descriptor used to centroid, and I'm going to turn off csound rendering. Press save. AudioGuide will automatically re-render, reconcatenate, reload the corpus, whatever it has to do. It will also, of course, write all the output files, and this updates our Bach roll file. So let's open MaxMSP and take a look at Bach roll. So this is a patch that's included in MaxMSP in the distribution /Bach. It's called AG Playback. And this lets you examine, sort of explore, listen to different components of a concatenation, and also sort of play them back, albeit in a somewhat hacky way. We'll start by simply opening the Bach roll file that we just created. And you will see here a representation of the target sound and all 3 members of the corpus put into separate voices. So the cool thing about this right away is that you can click on any note in this Bach roll, press the key V, and because I've created a little player here, it will play back the segments that you see on this, that you've selected for you.
The lecture is so soon.
Okay, so there's a way to individually audition different elements that have been picked, that are different elements that have been selected from this concatenation. You can also go ahead and simply play back the output file. This will essentially go through for both the target and the corpus, the segments in time, and play back essentially the version of the concatenation. It'll sound pretty similar to what csound was creating before.
The lecture is so soon that I don't think I'll be able to get.
Now, I should mention that the playback mechanism is, I said it was a little bit hacky. It's done with SF Play, which means that it's quick and easy, but SF Play obviously has some drawbacks. It's loading sound files immediately from disk and playing them. And so when you get really dense concatenations, this starts to fall apart and not work as well. But just for listening and auditioning the data that AudioGuide has created, this is pretty useful. Now, there's a couple of Bach options that you can put into your options file to change the default behavior of how a concatenation is written to the Bach roll. If I include target, set include target to false, it's not going to write the target sound file anymore. You can change information about the clefs, the default clefs for both the target and corpus entries. And again, if I just save this options file, AudioGuide's going to, because it's in interactive mode, automatically re-render a new Bach roll for us. You can see it responds. I come here, and now we have a version where we have, I've taken away the target and I've put the corpus on a single treble clef staffs rather than the ground staff. Let's go back to the ground staff because it's a little easier to read. And let's turn the target back on. Again, save, automatically reruns AudioGuide because it's in interactive mode. And we're back to where we started. So I want to say a comment about what you're seeing on the screen, and that is that to make Bach roll work, at least the version I decided to pursue, AudioGuide has to be able to assign a pitch to every event, every target segment and every corpus segment. This can obviously be tricky because some of the events are noisy and don't naturally lend themselves to a fundamental frequency analysis. And by default, the way AudioGuide is going to be deciding on MIDI pitch information for both target and corpus segments is a variable in the TSF or CSF objects called MIDI pitch method. A MIDI pitch method by default, if you don't write it, its default operation is to look for a pitch written into the file name of the segment in question. If it can't find one, if it can't find a MIDI a pitch number like F#4, it's going to use the average F0 for that segment. That's the default behavior. You can change that behavior. So for instance, here in this options file, I've set MIDI pitch method to a float. That simply just gives one pitch to all the segments for this particular collection, in this case, the corpus. I just changed it to 54 from 60. If I reload Bach, you'll see corpus is now written on F# rather than on C4. So there's a bunch of interesting choices you could make here. There's for MIDI pitch method to represent the pitch data of unpitched sounds or sounds that don't have a clear F0. One is you can actually use a descriptor and take all the sounds from a corpus sound and remap it between a low pitch and a high MIDI pitch, which is what I'll do here for Lackaman. So now we'll get the same concatenated outcome just with a different pitch representation for the Lackaman sound file entry. Okay, so the reason playback works in AudioGuide, in Bach rather, is that AudioGuide puts into Bach's slots a bunch of information about these sounds, these notes. They're not simply notes with pitches and durations, but they have the full path of every sound written into them, into slot 1. They have this skip time into the sound file in question, meaning if they start at 0 in the sound file or if there's a delay in the sound file, excuse me. There's a slot for the number of channels that each sound file has. There's a slot for the envelope of each sound. You'll remember from a previous video that every corpus sound has an envelope by default that you can edit with this onset len and offset len keyword argument. Here I've made the heat sink so that it's 50% rise and a 50% fall. So it's got a fade in and a fade out, whereas you can see the other segments have a more traditional 10 millisecond onset and a 40% decay at the end of the sound file's duration. So this envelope information is part of the playback routine that's used here. And when you scale dB, when you change the volume of a CSF or TSF object, that's going to be reflected in the envelope data that's put into Bach. There's a transposition for all the sounds, and there's a selection number. The selection number for the target says how many sounds were picked for this target segment. And for the corpus, for each sound that's on the screen, the selection number tells us which selection this sound was for the target segment in question, meaning 0 was the first pick sound, 1 was the second pick sound, 2 was the third pick sound for this target segment with 3 selections. So there's some interesting data here by default that's put into AudioGuide slots, box slots. You can edit what data goes into what slots with this dictionary argument called Bach slots mapping. Here I'm going to use all the default mappings for file path, skip time, SF channels, env, transposition, and selection number, but I'm also going to add some descriptor data. AudioGuide lets you put descriptor data in any of Bach's slots. You can put a list of segmented descriptors like I've done here and here, and you can also put a time varying descriptor into any one of Bach's 30 slots for each note and get data, descriptor data essentially, for both target and corpus segments in the Bach roll. So here I'll save. You can see AudioGuide's rerun the rendering portion. If I load the new Bach roll, it should look the same because we haven't changed anything about the concatenation. We've only changed the data that's in Bach slots. And when you click on every note in Bach, you can press numbers on the keyboard to view different slots. I'm going to press 7 to view the 3 centroid metrics that I've loaded in from the descriptors. This is average centroid, minimum, and maximum for every target and corpus segment in slot 7. Slot 8 has all 12 averaged MFCCs for every event. And slot 9 has a time varying descriptor, in this case amplitude. And so time varying descriptors will obviously be of different lengths depending on the length of the sound. So here we've got a relatively short segment with only about, looks like 10 array values. For longer corpus or target segments, you'll find that slot 9 will have a much longer time series because it's the time varying amplitudes. So that's a little bit about how Bach works. And again, it works really nicely in this interactive mode because you can really easily change, let's say, the descriptors. Press save, AudioGuide will automatically concatenate and recreate the Bach roll file. And now we've got a new version of this target and this corpus using a new descriptor.
The lecture is so soon.
That's kurtosis. Let's try one with flat. This is, okay, AudioGuide's done. Here's one with spectral flatnesses.
The lecture is so soon.
Bach is a really well-developed, mature program. There's some notes about different things you can do in here to, for instance, automatically change the clefs to adapt to the pitch content of the different systems on the page. There's also ways in Bach to solo different portions. So if you click on the clefs of a particular voice and press the solo button, playback will then only play that voice. And so it's a really flexible environment, not just for playing back and exploring things, but also for processing and manipulating the note data that you see on the page. So that's all I want to say about the Bach roll output, except that I should also mention that one of the reasons I integrated Bach output into AudioGuide was because I wanted to find a way to write music for acoustic instruments. Here we've just looked at Bach as kind of a way to represent any sound file data, whether it's pitched or unpitched, whether it's instrumental or otherwise. But there's a whole additional infrastructure within AudioGuide for writing for instruments. And I'm going to talk about that in a separate tutorial after this 5-part series on the tutorial page. So please check that out if you're interested. The final thing I want to say is there's two other ways to work with AudioGuide's output that are a bit more advanced. The first is just that AudioGuide by default writes this JSON data. And if you're in a program where you can parse JSON data like MaxMSP, you'll find that it's pretty easy to grab AudioGuide's output and use it for a different programmatic purpose. So the default JSON output.json file that AudioGuide creates has information about the target sound file and all the target segments. It's got a list of all the corpus sounds that are used. And then it's got a list for all the selected events from the corpus with all of the, as a list of dictionaries. So it's really easy to work with AudioGuide's output format in this JSON way. The final thing I want to say is that AudioGuide also has a rather crude but functioning API. And so if you want to use AudioGuide in your own Python module, it's relatively easy to do so. You simply import AudioGuide as a module, and then this example, API example that's in the main directory of AudioGuide's distribution has some information about the ways that you can run the concatenative process and view and manipulate and grab data from the output to suit your own needs. So this video marks the end of the 5-part tutorial series. I know it's been long and detailed, but I hope it's been interesting to get to know the program a little bit and get a sense of what AudioGuide can do. I'll be posting some more tutorial videos after this kind of core 5-part series that I've put up. I've already got one up about working with AudioGuide in interactive mode, so you understand how that works. I'll be revamping the writing for instruments video soon so that I can give you a clearer overview of the ways that you can use AudioGuide to create acoustic music and also mixed electroacoustic music. So please stay tuned for those.